This is lesson 11.1, Simplifying Radicals. Our first vocabulary term is radical expressions. Radical expressions simply contain a radical. So, for example, 2 square roots of 3 is a radical expression, and the square root of the sum of x plus 3 is a radical expression. We also have two properties we'll be dealing with in this lesson. The first one is the multiplication property of square roots. And it says, for every number a is greater than or equal to 0 and b is greater than or equal to 0, the square root of a times b is the square root of a times the square root of b. For example, if you have the square root of 54, you could break it down to be the square root of 9 times the square root of 6, since the square root of 9 times the square root of 6 is the square root of 54. And then you could take the square root of 9 and get 3. The square root of 9 is 3 times, and you cannot take the square root of 6, so we leave it in the radical, and you end up with the answer 3 square roots of 6. So your book uses this same method that we just looked at to simplify radicals. But I have another method, so I'll show you both, and then you feel free to choose whichever method you prefer. So if we were to simplify the square root of 243 using the book's method, the book would want you to find a perfect square times another number. It would want you to find two factors of this number, one of which being a perfect square. And we could break down the square root of 243 to be the square root of 3 times the square root of 81. And 81 is a perfect square. 81 times 3 is 243, so this is still the square root of 243. The square root of 3 times the square root of 81 is still equal to the square root of 243. But now we can take the square root of 81. So we have the square root of 3, can't take the square root of that, times the square root of 81 is 9. So we end up with 9 square roots of 3. And that's great if you can quickly see, or if you can quickly find the perfect square factor of your number, then that is a great, quick, and easy method. However, it's not always easy to find the perfect square, so here's another way you could work the same problem. You have the square root of 243, so break it down into all its prime factors. So I see 243 is divisible by 3 because 2 plus 4 is 6, plus 3 is 9, and 9 is divisible by 3. Therefore, 243 is divisible by 3, so I have 3 times. If you use your calculator and do 243 divided by 3, you get 81. And then I'll just break down 81. 81 would be 9 times 9. Well, 9 is 3 times 3, so there's one of my 9s, times, and the other 9 would be 3 times 3 as well. So then if you put this back in your calculator, you always want to check to make sure you accounted for all your factors. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is in fact 243. So these two are still equal to each other. Then we just want to find all our pairs. Well, I have one pair of 3's here and another pair of 3's here. The reason we're finding our pairs is when you multiply them together, 3 times 3 is 9. You can take the square root of any pair. What's the square root of 9? Well, it's just 3. So pull out a 3. So basically, I took this 3 times 3, I took 9, and took the square root of it. So now it's not under the radical anymore. Then you can do the same thing with this pair of 3. 3 times 3 is 9. So the square root of 9 is 3, and it comes outside the radical as well. But this 3 has to stay under the radical. When you simplify, 3 times 3 is 9, 9 square roots of 3, and you get the same answer that you did before. Let's try both those methods on a couple more problems. So on A, the square root of 50, the first thing I would think is 2 times 25. Well, that works for us because the square root of 25 is a perfect square, so I can take the square root of it. So I have the square root of 2 times the square root of 25 is 5, and then we always put our whole number in front. Your radical should always be at the end, so we have 5 square roots of 2. And these radicals, they kind of work like x terms. If this was x times 5, you do 5x. So if it's square root of 2 times 5, you have 5 square roots of 2. If we were to have used my method, we would have had the square root of 50 equals, and then break it down to its primes. 2 times 5 is 10, times 5 is 50. And then like we did before, find all your pairs. We have a pair of 5s. 5 times 5 is 25. The square root of 25, so pull it out. The square root of 25 is 5, and 2 is left inside. And you notice, again, same answer. let's look at B. So leave the negative 5 alone, leave it outside, and then the square root of 300 we want to break up into two factors, one being a perfect square factor. So let's see, 2 times 150, neither one of those are perfect squares, so 3 times 100, 100 is a perfect square. So, sorry, I didn't mean to put that equal sign there. So I have negative 5 times the square root of 3 times the square root of 100. And again, remember, we're using that perfect square because we know we can take the square root of it. And we want to basically think of this radical as like jail. You're trying to break this number out of jail. But if you can't break the whole number out of jail, you want to break out as much of that number as you can. So we're going to break out this 100 out of jail. So keep your negative 5 times, and then can't do anything with the square root of 3, times the square root of 100 is 10. Then remember, we always want our radical at the end, so make sure you multiply these whole numbers together. Negative 5 times 10, negative 50, square root of 3. And then, like I said, if you're going to do it my method, negative 5 square roots of, break down 300 to its primes, so it'd be 3 times 100. 100 is 10 times 10, and 10 is 2 times 5. And we said it was 10 times 10, so 2 times 5 again. And then remember to always check. 3 times 2 is 6, times 5 is 30, times 2 is 60, times 5 is 300. And then remember to find your pairs. So we have a pair of 2's. So I have negative 5 times 2 times 2 is 4. The square root of 4 is 2, so I busted out the 2. And then I have a pair of 5. 5 times 5 is 25. The square root of 25 is 5, so I busted out the 5. And then I can't do anything with the 3, so the square root of 3 stays underneath the radical. And then you just multiply all these numbers together outside. Negative 5 times 2, negative 10, times 5, negative 50, square root of 3. Same answer. Last one, the square root of 18. So, like I said, these numbers are pretty easy to find that perfect square factor for, but not all your numbers will be, so sometimes this method is a little quicker and easier to see. But on the square root of 18, it's real easy to think of that perfect square factor, the square root of 2 times the square root of 9. 9 is our perfect square. 9 times 2 is 18. Can't take the square root of 2 times the square root of 9 is 3, and then remember, always put your number first, just like x times 3 would be 3x. The square root of 2 times 3 is 3 square roots of 2. And with my method, we would have just done the square root of 18 equals 2 times 9. 9 is 3 times 3. And then you would have seen this pair of 3's. 3 times 3 is 9. The square root of 9 is 3. So 3 gets to come outside the radical, but 2 has to stay inside. 3 squared to 2. Same answer. Okay, in example 2, we're still simplifying radicals, but now we also have to deal with variables. Don't worry, it doesn't get too much more difficult. So again, using the Book's method, they want us to find the perfect square factor of 28 and times another factor. So we could break down 28 to be the square root of 4 times the square root of 7. 4 is our perfect square factor. Times, now x to the 7th would be the same thing as x squared times x squared times x. So I took the square root of x to the 7th and I rewrote it as the square root of x squared times the square root of x squared times the square root of x. Because x squared times x squared is x to the 4th. Oops, I didn't finish, did I? X squared times x squared is x to the 4th times x squared is x to the 6th times the square root of x. That's why it's always good to go back over and check what you did, because sometimes we make mistakes. Okay, so now we're going to apply the same method we do to our numbers with our variables. So the square root of 4 is 2 times the square root of 7, we can't do anything with that, times the square root of x squared. Basically, the square root and the squared cancel each other out. So the square root of x squared is just x. Because remember, when you're taking the square root, you're finding what that number is, or what that letter is, that you'd multiply times itself to get x squared. And x times x is x squared. Same thing here, square root of x squared is x times the square root of x squared is x. We cannot take the square root of x, so we just leave it inside the radical. Then we always want to put all of our factors or our numbers together that are outside the radical. So I have 2 times x times x times x, x times x times x is x cubed. And then put those numbers or letters or factors that are under the radical together. So we have the square root of 7x. 7 times x is 7x. The square root of 7 times the square root of x is the square root of 7x. There's your answer. Now, my method, we would do the square root of 28x to the 7th equals, and then again, break down your number into its prime factors. So 28 would be not its prime factors, into its prime factors. So the square root of 28 would be, you could do 2 times 14. 14 would be 2 times 7. So 2 times 2 is 4 times 7 is 28. And then x to the 7th. So 7x's. 1, 2, 3, 4, 5, 6, 7. Remember that all you have to do is have a pair of numbers or letters to bust them out of your radical. And that's because 2 times 2 is 4. So if you take the square root of 4, you get 2. So it comes outside the radical. 7 has to stay in because we can't take the square root of 7. Then x times x is x squared. The square root of x squared is x. So it's outside the radical. Same thing here. X times x, x squared. The square root of x squared is x. Same thing here. So we have another x. So we pulled out those 3 pairs, and x has to stay inside. So then you have 7x left inside. And when we simplify, 2 times x times x times x, 2x cubed times the square root of 7x. So again, notice you get the same answer either way. All right, let's quickly try and do a couple of quick checks here. And I'm going to start exclusively using the other method of breaking it down into its primes. So 27 would be 3 times 9. 9 is 3 times 3 times n times n. So remember, we're just looking for the pairs. And again, if you want to use the method the book does, that's fine. So I have a pair of 3's and a pair of n's. So that means I get to pull out a 3 and an n, and then 3 is left inside. Again, that's because 3 times 3 is 9. The square root of 9 is 3. N times n is n squared. The square root of n squared is n. That's how those got to come outside the radical, and 3 had to stay inside the radical. Okay, let's look at B. So I have negative a outside, and then the square root of, and I want to break 60 down into its primes. So 60 would be 2 times 30. 30 would be 5 times 6. 6 would be 2 times 3, and you always want to check. 2 times 5 is 10, times 2 is 20, times 3 is 60, times, then we have a to the 7th. 1, 2, 3, 4, 5, 6, 7. And then again, just pull out the pairs. So I have, let me bring down this negative a times, because everything's multiplication. So everything I pull out, I multiply times the negative a. So I have a pair of 2's. 2 times 2 is 4. The square root of 4 is 2, so it's out. Then I have a pair of a's. The square root of a squared is a. Another pair of a's. The square root of a squared is a. And another pair of a's. So the square root of a squared is a. And then what's left inside? 5 times 3 times a, so the square root of 15a. And we can simplify all this out here. Negative a times 2 times a times a times a. I have a negative times a bunch of positives, so it's going to be negative 2, 1, 2, 3, 4, a to the 4th times the square root of 15a. All right, last one. We got to hurry. The square root of x squared, y to the 5th. So I have x times y times y times y times y times y, 5 y's. Find your pairs. Pair of x's, pull it out. Pair of y's, pull it out. Another pair of y's, pull it out. So no equal sign there. Trying to hurry too fast. And then y has to stay inside. It didn't have a buddy to break out of jail with. So then we have x times y is xy squared times the square root of y. All right, in the next video, we'll do another couple examples.